I'm Paul Ferraro, professor at Johns Hopkins University in the US. I'm co-moderating this panel along with Sebastian Costa-Doat from Conservation International and Rachel Martin from Conservation X Labs. This is the 8th seminar in our seminar series. If you missed last month's seminar by Jennifer Alex Garcia on the issue of measurement error in satellite data and how it affects impact evaluations, you can see the recording on our Vimeo site. We'll be putting that link in the chat box. And we'll be having another one next month that I'll talk about at the very end of this seminar series. If you haven't been here before to any of our seminar series, we're going to start with the panel. Allow the panel to give short presentations and then some follow-up, and then we're going to allow them to answer questions from the audience. So for that moderated Q&A session, you can post questions in the chat box. There won't be an opportunity to unmute and ask the questions, so please put them in the chat box. You can start doing that early. That will give our team an opportunity to work through those questions and curate them and collate them. If you find it helpful, you can activate the live transcription function in Zoom. Look on the menu ribbon under More and choose Live Transcript. If you have to leave early or know someone who wanted to be at this seminar but couldn't make it, the recording will be available at the link there that we put in the chat box for you to use or share with others. And if you want to engage with us on social media, use the hashtag Tuesdays with Team Counterfactual and tag @IDoImpact, which is the Twitter handle for the Society for Conservation Biology's Impact Evaluation Working Group. If you haven't joined it, I encourage you to do so. If you're here at this talk, you're interested in evidence-based conservation action and impact evaluation. There's a variety of ways to get involved. We'll be putting those links in the chat box. And for today, we're here to hear a panel talk about counterfactual methods and their use in the voluntary forest carbon market. We've got a great panel. We're super excited that they were willing to participate in this. If you're not aware, the motivating reason for having this panel was a Guardian story and associated studies, analyses, rebuttals, and critiques around it. When we saw all of these articles and the engagement, we saw a lot of smart folks. We saw trying to address challenging problems and a lot of reasonable disagreements. And we thought it was a great opportunity to contribute to advancing the dialogue among these groups that are all interested in reducing deforestation and mitigating climate change. All right, so just to make sure we're all clear on what we're focused on today, this is Team Counterfactual. So we are focused specifically on the challenge of quantifying additionality. Magnitudes matter in this context, and the magnitude we're interested in is the difference between how much forest or emissions we have after an action is taken and how much we would have had in the absence of that action. And so the challenge here is estimating that counterfactual deforestation or emission trend, or as it's known in the carbon credit world, the baseline. Now that's what we want the questions to focus on. So the panels focus on is this methodological issue. There's lots of other important issues in carbon credits and avoided deforestation projects, but we're going to try to stay focused on this particular element. And before I switch over to the panel, I just wanted to highlight, from my perspective, someone who works on impact evaluation, causal inference, but not in this context. I see some serious challenges in particular in this context. And the first one is that everybody seems to be seeking individual level treatment effects, site level additionality. Right? And if we know anything from all the work that's been advanced in causality over the last few decades, is this is one of the most challenging things to estimate or quantify. Right? Even randomized experiments cannot estimate these effects without a lot more assumptions. So we've got a very big challenge. Also, we have both prediction issues and estimation issues. We've got ex-ante prediction for where do we put these projects, how do we issue credits early so that they have funding to actually do the actions they want to do. That will lead to particular methodological approaches. We also have the estimation problem for credit verification. That's going to lead to different methodologies, and how those interact still needs to be worked out. And then most importantly, when you read the debates, there are reasonable disagreements about what are the right confounders to control for it in order to be able to get the appropriate comparison or reference sites. How do we address noise, the stochastic nature of these systems? What's the right units of analysis? What's the right specifications for the model? How do we deal with interference or spillovers among the units? There are going to be reasonable disagreements. So how do we quantify our uncertainty about the magnitudes of additionality? And how do we communicate that uncertainty to the relevant stakeholders? All right, so you didn't come here to hear me talk. I'm going to switch it over. Our first speaker is going to be, let me stop sharing, Julie Baroody from Verra. We are not going to be introducing our speakers with all their background because we want to let them talk, but we will be putting in the chat box links to their pages if you haven't already looked them up beforehand. But without further ado, Julie, why don't you take over?
Thanks very much, everyone. And thanks for having me here for this great panel. I am honored to be among the esteemed panelists on this Society for Conservation Biology event. I'm Julie Baroody. I am Senior Director of Forest Carbon Innovation for Verra, which our mission is to accelerate action on climate change and sustainable development through standards that you see here that drive action on that contribute to measurable and high integrity outcomes for global stakeholders. So we have our primary standard, which is the verified carbon standard, and we then have our jurisdictional nested RED framework. Those are two primary carbon standards. We also have sustainable development standards, and I'm happy to take questions from anybody about those at another time. Feel free to email me. My address is going to come up at the end of this session. But we're here today to talk about RED and current methods and motivations, current methods for accounting for deforestation. So deforestation is particularly tricky to establish baselines for because of the many contributing factors. Deforestation drivers are not just physical, they are economically and socially driven as well. And so we all know that setting counterfactual baselines in any context is challenging, but in this case, it's particularly challenging. Right now, using reference regions to establish through time what would be a without project scenario or counterfactual case for the project intervention is the only option available to projects in the voluntary carbon space. We are constantly trying to improve our methodologies, and with technological advances. So just to go back to the reference region approach, this was developed 10 years ago by the world's leading forest carbon experts and academics, and it had extensive consultation, and it has been refined and improved over time. Our 5 different avoiding unplanned deforestation methodologies each have slightly different approaches to setting reference regions, and so that's one of the things that we've been trying to address. Because of technological and advances and increasing data availability, we're finally able to do this. So we want our methodologies, as we call them, to be as workable as possible, which means that the data and technology have to be available to project proponents, validators and verifiers, and to the standards body so that we can review the projects and make sure that those baselines are as credible as possible. So credibility is important for a standards organization because we want one verified carbon unit that's generated under the verified carbon standard to be the same as any other unit. And then the other driver pushing us to change methods is this alternative or alignment with this need to align with government actions and accounting. So the United Nations Framework Convention on Climate Change is pushing this through the Paris Agreement, and all countries are wanting to move toward this new approach of government alignment. So here are some of the new methods that we are thinking about. One is synthetic control points, such as those that were used in the studies that we're talking about today. We are not opposed to the synthetic control points at all. This approach, we currently use it in some of our new improved forest management and the forthcoming afforestation, reforestation, and restoration methodologies. And there is the potential, we're working with partners, including Pachama, to look at this for future forest loss or disturbance methods in non-REDD countries, and potentially for avoided plant deforestation. But the real way that our avoided unplanned deforestation methodologies are going now is to a risk-based jurisdictional allocation approach. So this is where baseline data is allocated by Verra based on the risk of deforestation in the project area. And so this ensures that project accounting is aligned at the jurisdictional level in keeping with the UNFCCC, REDD, Paris Agreement, and NDCs. And it will ensure that all baselines are at what generate emissions reductions that are, when added up, no larger than the total emissions reductions that could be issued in a jurisdiction. So that's a specific way that the allocating robust jurisdictional baselines is a specific way that we are constantly evolving in our approach to deforestation accounting. We also have, over the past couple of years, instituted shorter baseline periods for REDD projects so that they have to update their baseline with more frequency. We went from 10 years to 6 years. We are implementing digital measurement, reporting, and verification approaches for both for long-term right now, and then also in the future, hopefully for shorter-term approaches. And then, as you may all know, we are consolidating all 5 of our avoided unplanned deforestation methodologies into one. And so in a few years, we'll only be dealing with one methodology, which will eliminate a lot of the inconsistencies that currently exist between those methodologies. And so hopefully in the future, there will be that's it.
Thank you, Julie. I appreciate it. Our next speaker is going to be Thales West from the Vrije University in Amsterdam. So you can stop sharing your screen slides, Julie, and then tell us you can start.
All right. I trust that you can see my slides now, right?
I cannot. I see that it says start screen sharing. There we go. Now I can see it.
Okay, good.
Did we just lose him? I think we may have. So why don't we move to Tom?
Sorry, Paul, I'm back.
Oh, you're back. Great.
Well, I'm sorry. I just got a message saying that Zoom was about to crash or something. Isn't that great? But let me try again.
All right. We'll start the clock again, Thales. No worries.
Okay. All right. So you should be able to see my slides now. Is that right?
See the Guardian slide. Yep.
Wonderful. Okay, so let's start. Well, as you know, we are mostly here today because of this story that was published by The Guardian, right? You may also know that the story was based on 3 evaluation studies, all based on causal inference methods. Paul already covered this. But I don't want to spend time talking about these individual studies now. Rather, I want to talk to you about what I believe is at the core of the additionality problem that these studies have identified, which is the way that the REDD+ projects create their baselines. Okay, and that is essentially following one of these methodologies that you can see here approved under the VCS, the Verified Carbon Standard. So let's see how baselines are created according to these methodologies. Okay, starting with VM6, we have a project area, we have a reference region, and an overall baseline deforestation equation, okay, which is based on historical deforestation observed inside the reference region. Julie was just talking about this, right? So deforestation enters this equation either as an average or as the lower bound of the confidence interval of a forecast from a beta regression. Although it's my understanding that VM6 actually uses a linear model, but anyway, the historical deforestation from the reference region, and this is important, is proportionally applied to the project area. right? And then we have a discount factor that makes the baseline, according to VM6, more conservative. Of course, there are some strong assumptions here, which are that historical trends will continue into the future and that the reference region is actually a good reference for the project area, okay? Now, VM9 is similar to VM6, but the historical deforestation from the reference region is used to fit a logistic regression, which is then used to forecast the baseline deforestation for the project area. Now, if you have experience with logistic regressions, you may know that they could lead to potentially an artificial explosion in deforestation during the initial years of the project, which is not great. And there's also no conservative discount applied in VM9. And again, we have the same strong assumptions for VM9 that we had for VM6. Okay. Now let's talk a little bit about VM7 and 15 together, because essentially they're very similar when it comes to creating baselines. Again, we have a historical average or a forecast based on the reference region, but unlike VM6 and 9, the rate of deforestation is not proportionally applied to the project area, but it is allocated across the reference region with the use of a spatial simulation model. Okay, so maps are created. So you could, for example, have a baseline map that looks like this. In this case, no deforestation was allocated inside the project area, so the baseline deforestation is 0. This project would issue no carbon offsets, essentially. But you could also have a very different baseline map that looks like this. And in this case, deforestation was allocated inside the project area. You would have 100% of deforestation in this case. So this project, under this baseline map, would issue a lot of more carbon offsets, or a lot of carbon offsets. So oftentimes you have to make a decision which baseline map to choose. And sadly, the reality is that with high flexibility, lack of transparency, and poor model validation requirements from both VM7 and 15, experienced modelers can create almost any baseline scenario they want. Okay, so just to conclude my point with an empirical example, what we have here are the locations of 4 REDD+ projects and their reference regions. And let me just show you what can happen when we use these different VMs to create baselines for these project areas. Okay, well, this is what happens. We are looking at here the baseline deforestation over time in the blue areas. We see no consistency across these baselines and methodologies. And just keep in mind that, at least in theory, these projects could have adopted any of these baselines as their official project baseline. Okay, so yeah, I'm almost out of time. I'm going to stop here, and I'm going to let you draw your own conclusions from what I just shared with you. Okay, thank you very much.
Thank you, Thales, for sticking in time and getting a lot of information in there. Appreciate that. Our next speaker is Tom Swinfield from University of Cambridge and 4C. Get away, Tom.
Fantastic. I'm just trying to look. Where is the share screen button on this?
It's got it. Green.
I got it. That's cool.
Got it. All right.
Sweet. Okay. Can you see my slides?
Yes, they're not maximized, but we can see them. There we go. Perfect.
Okay, great. Okay, so I'm Tom Swinfield. I'm from the Cambridge Centre for Carbon Credits. We're interested in producing credible carbon credits in a scalable way. I'm going to dive straight into what we're doing. So essentially, we have a matching method, which is based upon a simple project definition as a spatial polygon and a start date. And with that, we can take a sample of points from within that polygon, which are shown as these green dots here. And then we can match to a set of points outside of the project based upon being within the same country, biome, the same historical change in land cover, and the change in that land cover around those focal points as well, accessibility, population density, and some of these other variables that are important in matching. What we can then do is we can find a set of points which are very similar to the project outside, and we can show you which points are connected together. And then we can take some of those individual points themselves and we can see how similar those points are. This is just showing a subset of the matching variables, so that the control points are similar with respect to the drivers of land use change. And then we can take a large sample from the landscape, and we can use that to try and look at some outcomes. In this particular case, what we see for this project is that, yes, it experienced some deforestation over the project period. So that's the green line on this graph, but it didn't experience as much deforestation as we found in the counterfactual scenario shown in blue. What's really nice about this approach, I think the nicest thing is that it's very straightforward and intuitive to understand. And it's also built upon a sense of reasonable assumptions and defensible assumptions about how the counterfactual is produced. However, sorry, before I go into the howevers, I just want to say that the important thing is as well is that we need to move towards a system where we have a commitment to open sourcing these kind of evaluations so that the assumptions that are used are transparent and they're able to be reproduced by others. But also to note that these methods haven't been bottomed out. We don't know exactly how to do this in the best possible way. And so we need to bake in iterative improvability. The nice thing about doing this in an algorithmic sense like this and using statistical approaches is that we can implement this in a generalizable way without resorting to very, very specific project evaluations coming from the proponents themselves. And also that these can be done in a scalable and low cost way, which is really important if we're going to bring sufficient supply to market. As I've stated, and as Paul indicated earlier, there are issues with this. Which matching variables we use really does matter, and the outcomes are sensitive to these. So I just want to say that, there's going to be discussion about this. I won't dive into these individually, but maybe we can get into it later. There are issues such as we have to make trade-offs between finding the exact best matched set and having an assessment which is generally valid and not overfitted. And so there are some statistical issues that we have to take into account when we're doing this. And there are some challenges. What do we do if we can't find counterfactual points or matched points that are really similar to our project because it's so unique? And as Paul said, there are spillover effects. What happens if some of our counterfactual points have actually been exposed to a treatment, a project intervention that we're not aware of? Well, how do we control for leakage emerging from these interventions spilling over into our control region? I gotta hate this with Zoom where all of that Zoom stuff is all over your slides. But anyway, the important thing to state here is, as I think Thales has covered quite nicely, all of these issues also apply in the case of expert defined reference areas. On this slide here, what I'm showing in red is, again, a set of reference areas for a particular project. And I don't want to name names with this. This is a generally applicable problem. But what we've done is overlaid here our matched counterfactual points on top of it. And what you can see is that some of these areas match quite well. They're covered by these points. Other areas are not sampled at all, despite a really large sample set of points. We're not sampling from within those regions. And so perhaps it's no surprise that the counterfactual scenario that's been put forward by this particular project is quite a lot more pessimistic than what we observe when we look just at the match set. And so this is the dotted red line is the one that the project is actually using, and the one that we're seeing is for the blue dotted line. As an aside, I want to say that the other thing that we note here is that the project actually assessed itself to have less deforestation than what we've observed using a globally accessible deforestation project. We're using the Van Cutsem data if it's of interest. And I think that's quite important because this is despite claims that globally derived land cover change products are not as sensitive as locally produced ones. I'm going to make a quick tangent. Sorry, Paul, for doing this, but I think the same problems are on the horizon for permanence and leakage. Few buyers believe that natural carbon credits deliver permanent benefits, and we need to engage within permanent storage value. The second is that market leakage is hard to assess, but using conservative, generically estimated adjustments just aren't good enough. Projects need to prevent leakage, and they'll do that by maintaining production of the products foregone. And that includes things like food and fiber, and that can be done through increasing yield. But until we do that, we have to adopt more robust measures of leakage. Both of these issues, permanence and leakage, both require good counterfactual thinking, and that's why I'm bringing it up here. It actually does matter. So what we're doing at the 4C is attempting to combine robust adjustments for additionality, leakage, and permanence into what we're calling permanent additional carbon tons, or PACTs. And if you want to speak to me about that, you can get in touch with us. Finally, I want to say that this stuff is really important. We intuitively understand that cheap carbon credits don't offset emissions, but if we don't fix the credibility issue, then nature's potential to mitigate the climate crisis will not be realized. As Verra says, we can't let the perfect be the enemy of the good, but we can't let the non-credible be the enemy of everything. Thank you.
Thank you, Tom. All right, our final speaker will be Carlos Silva from Pachama. Oh, take it away, Carlos.
Let's see.
Yep, we can see it,
Yeah.
not maximized, and there we go.
Yeah, perfect. So it's a pleasure to be here. I want to actually thank the organizers first, because this type of exchange is really, really needed. And I hope this is just the first of many such type of fora. My name is Carlos Silva. I help lead Pachama's efforts to develop algorithmic baselines with the objective of building a future of high integrity, transparent, and scalable crediting. I want to start with a brief outline of the main areas that I want to cover. I'll first touch on 3 baseline approaches. This first compares a treatment group, in this case, the Carbon Project, and this is exactly what Tom was just showing, and Thales's work as well. And there are a variety of methods for selecting control areas that I think perhaps we can discuss today. The second approach actually applies at the level of a country or a subnational jurisdiction as opposed to an individual project. It's effectively a longitudinal analysis that quantifies observed reductions in deforestation over time. So you can think of this as simply a before and after comparison from the time the country enrolls in the carbon market. And the third is nesting, which I'll describe in more detail, but is really an approach that's specific to the carbon market that's driven largely by policy and practical considerations. And then I'll briefly describe a simple framework for computing based on uncertainty that applies regardless of approach. And lastly, I'll briefly touch on the relative merits of these approaches, but actually Tom said almost everything that I wanted to say on that. So starting with the baseline approaches. First, the treatment versus control. So Pachama has developed a control area baseline that matches, just like Tom was showing, each pixel in a carbon project, the most similar pixels in the surrounding region across a range of satellite observed attributes. And so here in yellow, you see a sample control area. The white shaded areas are existing protected areas that we exclude when we're sampling control pixels. Then, as you can see here, the control area selection ensures that the project and the control area, their feature distributions across the range of input features, that they match well. And this is just a sample of some of the features that we've been testing lately. And then to compute the baseline, we then simply observe deforestation that's shown here in red in the control area over time. And so I want to, it's an important thing, I think Thales brought up well, the problems also when you're dealing with, and one thing is a challenge of control selection. And then if you start getting into issues of forecasting the future, you get into more problems that we've been trying to avoid entirely. If you then just switch into a time series view of what I've shown, here's just an example. The green line is our central estimate of the control area's deforestation through time. I'll talk later about how we get that shaded region, the uncertainty interval. And then the orange, these are cases of actual project baselines used for crediting. Now, quickly, the second approach here, I'm not going to spend much time on it, but this applies at the level of a national or subnational jurisdiction. And this approach simply tracks observed reductions in deforestation over time relative to a historical baseline. It's that horizontal dashed red line. And then the vertical dashed line here indicates the year that country enrolled in the carbon market. So I don't want to dwell on this because really it's relevant only to projects with this approach that's called nesting, whereby we take a fraction of that historical baseline, that dashed red line, and we assign it, we'll allocate a fraction to a project using a deforestation risk map, like you see here. And so the red pixels here correspond to higher risk of deforestation. So each pixel has a probability of deforestation. And then by overlaying a project boundary on a map such as this, you can compute the expected deforestation inside the project. And this is referred to as nesting. So I'm sure we can get into details of these approaches, but regardless of approach, what's crucial for high quality credit, the important point here is to rigorously quantify baseline uncertainty. And placebo carbon projects offer a straightforward way of computing baseline uncertainty. And a placebo is just a randomly sampled forest area without a carbon project. So in the case, for example, of the control area approach, we can select a control area for each of these placebos. And because neither the placebo nor its control have a carbon project, in theory, we should expect their deforestation outcomes to match. And so here you can actually see placebos for a sample carbon project, the placebo deforestation on the lower, on the x-axis, the y control area deforestation. In the ideal world, they'd be perfectly aligned on the one-to-one line, but that's not obviously the case. We can then take this error and then turn it into a distribution across the baseline. And that's what I was showing previously with the shaded uncertainty intervals around the time series, baseline time series. So One other thing that we've been testing is to validate baseline performance at the jurisdictional scale. And what we do here is each of these placebos, different colors, they represent a different combination of project size and deforestation intensity. And we're hoping in the near future to publicly share these files so to help facilitate intercomparison among researchers. So we put these on our website so we can have common sets of placebos for comparing baseline methods across groups. And then I probably am near out of time, so I'm not going to dwell on this because Tom, as I said, mentioned everything. The key thing I do want to point out that I saw that Tom also mentioned here, the control area approach we think is excellent. There is an issue at scale, perhaps, with finding sufficient areas for control because you need to enforce non-overlap for control areas between projects. And the important thing about nesting, and this is what Julie was mentioning as well, is that there is this separate jurisdiction level crediting market, and there's a need for harmonization and crediting between the two markets to avoid double crediting. And so that's a kind of a practical advantage of the nesting approach I showed. And then quickly, we're committed to transparency. We want to be collaborating with a lot of groups. We put a research brief out there that hopefully will be shared in the chat. We shared a couple of weeks ago, and then we're working on a validation document that we'd like to share for review in the near future. So I'll leave it there for questions.
Great, thank you, Carlos. Now we bring back all the panel. That was a lot of material that everybody squeezed into 5 minutes, and we appreciate everybody staying roughly on time. We're a little bit behind, but not a big deal. So what we want to do is allow speakers just a few minutes to react to what they saw or anything that they didn't see that they thought should have been addressed. And just to move things along, I think I'm just going to call on people. That way we can move along. And maybe I'll just go in reverse order. So Julie got a chance. She went first and then got a chance to see everybody else's talks. So Julie, do you have any reactions that you wanted to highlight?
Sure. So I don't want to go through the technical details. We have a technical response posted on our website, which was posted in the chat earlier. But I just want to emphasize that Verra operates in the context of the voluntary carbon market. And so we have a little bit different constraints than just the technical accounting of the forced carbon loss. And so we do have mechanisms to what Tom was talking about to ensure permanence. So we have a buffer pool that projects have to contribute a certain percentage of their credits to. And we do have, as Carlos alluded to, a jurisdictional and nested RED program where we want to align with the jurisdictional baselines. So I wonder from the panelists what you think are the potential opportunities to merge the methods that you're using with a jurisdictional approach, which countries are going to be interested in for the future. So if you anything we can learn from you guys, we'd really appreciate it.
Yeah, so why don't we that's a great question. This tension between practicality and the technical issues. Does anybody want to take that first? Just go right in. No need to be polite, go ahead. Carlos.
Yeah, well, so I mean, I was mentioning that that nesting is crucial for this sort of harmonization between what's attributed to the central government of a jurisdiction as opposed to what then is credited to the projects. And I think the crucial thing that I think that Thales was also getting at is going forward, regardless of the ultimate approach of switching to a validation of outputs and computation of uncertainty that then is applied to crediting estimates as opposed to specifying a detailed rule set on the inputs on the methodological side. And so, for example, and I showed you an example of those placebo, the control for placebo, where we have roughly unbiased. There's obviously spread, but it's unbiased. But you can get cases where you get a fair deal of bias. And so, we correct for that bias when we apply this placebo control error. And so if you, even if one says, here's the canonical risk map that we're going to use, I think there needs to be more flexibility, as Tom was mentioning, in terms of iterative improvements.
Thales or Tom, is there anything you wanted to add?
Yeah, I mean, I'll hop straight in. I mean, I'm concerned about the jurisdictional shift. The reason for that is because I think all of these same problems that we're seeing at the project level apply at the jurisdictional level as well. It's just moving it up a scale. And I think the thing we have to do there is to think carefully about what it means. Again, what are the sensible reference areas? One of the things that I was getting at was saying, do we match within a country? Do we match within a jurisdiction? There are reasons why you might do that. For example, being within the same policy environment. But when it comes to moving up to larger jurisdictional scales, it's hard to match on those bases. And so you're then having to look at this in more of an international way and finding places that are still similar with respect to their policy environment and also similar in terms of some of these specific economic drivers as well.
Thank you. That's good. So
I say something too?
Mm-hmm. Sure.
I think those are excellent points. And yeah, Stone was saying, as you increase your jurisdiction or you migrate from projects to jurisdictions, it's much harder to find controls, right? And on top of that, you could even run into issues when suddenly the controls start disappearing throughout time because more and more jurisdictions are created, right? So it's just an extra challenge that kicks in. It would be a bit easier to find controls for project areas, would be harder for jurisdictions. So it's really a big challenge. I don't think we have a perfect answer here.
And maybe just kind of just jump in and just to follow up on that. I think there's this issue of the dynamic inclusion of points as treated or controlled, which becomes an issue the more we have adoption of red projects or these kind of projects. So as you start to see more and more of the landscape being converted to, let's say, a red project, you have to then actually exclude that from your counterfactual set. And that same issue is going to apply at a jurisdictional scale as well, as Thales was saying.
Well, and just if I could respond to those responses, I think that as we start to see more jurisdictional action, the additionality of red projects will become less, right? So that will be, in the end, a good thing because we'll be mitigating climate change at a larger scale and forests will be kept standing. And so as governments start to take action and there are more government programs that aren't funded by carbon finance, that will be a net win for the climate.
I have a bit of a dissenting view quickly just to register here on the issue of scale. And so I think what we would do is you go to higher scale. That's why I put that second approach. You would switch away from controls. You know, all the macroeconomic literature, you get problems if you're doing cross-country analyses. In principle, we could have a global baseline, right? There's nothing from like a NASA satellite ESA perspective to say, here's the past global deforestation. Are we reducing deforestation? The buyer is then buying an observed reduction in deforestation. The only thing that prevents it is obviously like politics, you know. So anyway, I think we would at higher scale, you'd move away from controls.
But so I guess what I'm wondering is it important to know what's actually happening at every single project, or are we just trying to get this correct on average, right? At some scale, national or global? So I'm quite sure, like what Carlos, you just said, and even Julie, how you responded, are we, when we're scaling things up, whether it be it methodologically or just more and more projects are there, are we still trying to estimate accurately at every project level, or are we just trying to get things correct on average?
We definitely need estimate accurate, like accurate and conservative. If you can't be accurate estimates at the project level, if the projects are selling verified carbon units, at least.
I think it's a policy or a politics question. So as if we go, let's now to just like the optimal world, in my view, if you have a global baseline, you have by definition no leakage, you could then allocate credits by just some benefit sharing mechanism. It could be a risk map, but it wouldn't impinge at all on the integrity of the credits. Now, that's obviously not a near-term workable solution. So then to your question, Paul, about do we need it to be accurate at the project level or not, that's a question of, are you giving the credits, I think, allocated to individuals on the ground at the projects or to central governments? And then there's a sort of related question that is, what is at the level of a registry? And that's something that we'd be interested in, that's sort of, I think what Tom and some of the analysis tells us, like, what is the performance at the level of like the entire portfolio? So maybe we'll be wrong on a few projects here and there, but we want to have like a robust estimate at the level portfolio.
Okay. Any other reactions that someone wanted to have to any of the presentations, or something you thought was missing?
I guess I can go. I made some notes here. So it's very exciting just to see some how things are developing, right? And then more and more people are paying attention to these critical issues. Yeah, Julie mentioned technological advancements. Of course, we need them. More and more data is available. We should benefit from that information. But I would also say that you know, there are a lot of methods if you look at into the econometrics literature, there are a lot of methods out there that could easily be adopted to improve what we currently have, some of the current VCS methodologies, right? And why not do it? Why not try to benefit from what is already out there? Economists do this all the time. We don't necessarily need to wait for new technologies to come in. Of course, they are welcome, but we could be doing a lot better already, just looking at what is the state of the art that is out there.
So can I just ask you, do you think there is a best method out there, or that there's lots of methods and all have different problems and we should be doing some kind of averaging or ensemble approach across methodologies?
Well, I think the first thing that we need to do is to test all these methods. There are many methods out there. We don't know if they can be used or not, or how good they are, because we haven't really done the work. We haven't done the research. For example, it was mentioned that we could perhaps construct synthetic controls for countries and use that as some sort of baseline. Sure, but sometimes that approach doesn't work. I had a student last year, for example, who was trying to construct a synthetic control for Brazil, and it didn't work. Not because the methods are not there, but because the data was not really helping. We couldn't create a good counterfactual. Sometimes we have issues like that. A few weeks ago, also, I had a meeting with this economist from the World Bank. They were showing me some of their time series models, autoregressive models with lags, and how they were bringing in exogenous variables, and they were able, through their framework, replicate some of the historical patterns of deforestation across countries. So maybe you could benefit from an approach like that, which is not a synthetic control. It's only based on time series analysis. But yeah, there's some promising methods out there. What we need to do is to identify them and test them. Maybe there's a good method out there that we could use.
Sounds like we need a methodological summit. That would be a good idea. But I know there's lots more people who want to get in, but I want to make sure we have time for audience questions. So Seb, are you all ready to go on the Q&A?
Absolutely. Although
Okay.
I feel ashamed interrupting all the debate
No, go right ahead.
so far. And actually, the first question is for Thales. As you pointed out, that experienced modelers can create almost any baseline they want. But isn't the same critique level as scientists who use non-experiment data to estimate counterfactual outcomes? And there's a lot of questioning how robust is a synthetic control and how you can claim that's a true counterfactual out of this. So the audience would like to have some of you thinking about these methods and putting in balance the uncertainty. I mean, the challenges ex ante also apply ex post, but on a different level. So Thales, if you have any reactions.
I think that's a good point. What I can say in that regard is that it's still, even if you're looking at the ex post methods, if you compare them to ex ante methods, I would say that you have a lot more room and flexibility if you're working with ex ante methods, right? For example, when you're creating these baselines for red projects, if you use different algorithms, you can have very different outcomes. The way that you treat the variables that you use to create these baseline maps, they also can have a huge huge impact, right? When you're working with ex post methods, yeah, your model is subjective. I mean, it will vary depending on the specifications that you use. But I would say that overall, that can be a much more transparent approach. That approach itself would be more transparent. We have more control and understanding what are the impacts of different model specifications, for example, than we have when we're using the simulation models. But yeah, it's a fair question. There's no perfect method here. You could data mine your entire data. that would affect your baselines, right? But still, I would say that they are much more flexible and much less transparent when you're using the simulation models.
A very quick reaction from Carlos.
No, I just was going to say, I wanted to, again, bring up the idea of placebos for sort of transparent communication of uncertainty to the public. I think that's to the questioner there, that's a direct test of how well does your counterfactual perform and it allows you to directly measure that. And I spend a fair bit of time also talking with buyers, companies, like out in the real world. And so, there is a constraint here where we need a system or sort of an approach that enables a very simple, straightforward kind of conceptual underpinning for uncertainty computation. And I think, anyway, so I just want to remind people of that and that.
Okay, so
Can I jump in quickly? I think there's an interesting point here, which is the placebo approach. I think what it's going to allow us to do, what it allows us to do is to see the amount of variation ex post. What we want to do is to move towards counterfactual construction that really makes that ex post variation observed across the placebos as small as possible. And so we want to be working towards that.
Okay, so a lot of work to do, a lot of innovation needed. But in the meantime, there's very interesting question that is, I am yet to hear anybody on the panel defending the quality of Verra's current methodology and the ability to capture the causal impact of the project. And exactly the question is, what is good about the current system that we should not lose? And the question is obviously for Julia. Julie.
Thanks very much. Yeah, happy to address this. I think, so we can't, as I said before, the methodologies that we have now are basically the only way of calculating avoided emissions in the voluntary carbon market. And Verra is all in favor. We want to emphasize the mitigation hierarchy. So we don't want to enable folks to offset without taking their own reductions first. But there's two values in using carbon credits, and especially credits from avoided deforestation, after you have taken all the emissions that you think you can take at the current time. And one of those is simply accounting for taking full responsibility for your impact. And then secondly, it's keeping forests standing. Because once we lose those forests, they're never going to be put back in the same way that they are now. And it's just, and it will require so much more mitigation. And so we need to be moving on from the current approaches, and we are doing that. But for now, we still stand by all of our current methodologies as the best in class, and we've reviewed them over the years. We will be revising certain parts of them going forward until we have this new methodology in place, at which point in time we will phase out the current methodologies, at least the avoided unplanned deforestation part of them. And a lot of the parts of the methodologies, and too many to go into here, will still, all of the accounting is still valid and will continue improving. Somebody said earlier, like, why don't we just use all of the best new approaches? And that's what we count on you all to help us develop. So we work with a lot of academic papers and new science, and then have it tested in the field. And so that's why we're using synthetic controls in some of our new methodologies and dynamic performance benchmarks. So yeah, welcome anyone who wants to help us evolve in the future. But we do stand by our current methodologies as well as the forthcoming one.
And so, Julie, can I follow up on that? And any suggestion for the science community to follow up with you and collaboratively, improve the methodology? Do you have some practical recommendation moving forward? I'm asking to you first before expanding to the rest of the panelists.
Yeah, I don't have any specific recommendations here. I would just encourage anybody to reach out to myself or any of my Verra colleagues who you're in touch with regarding anything that you think that we could do better, or any particular area you have for us to develop in. We are really open to partnerships and testing things and piloting them going forward.
Great. Any reaction from the other panelists?
I appreciate Paul's point about placebos, and I need to, consult with others about, some more of the details there. But one thing on the way Verra might switch that we have in mind is a repository of placebos, where essentially, that would be, one is Verra does all the computation, or the algorithms is held by another party, but even then it needs to be validated by someone. And so Verra would say, hey, we're going to test your method with these placebos, and then Thales's method or Tom's or Pachama's, and we're all sort of then comparing on a level playing field for sort of consistency. I appreciated Thales' presentation about the kind of existing lack of unification that causes additional uncertainty or sort of confusion in the market. One other thing I just want to bring up for the group to comment on is there's another big problem that people always ask about, which is high forest, low deforestation. And I don't know, hopefully that means something to people here, or just quickly clarify is, what do you do for counterfactuals or a country that has a lot of forest but no current deforestation? And is there any way to provide crediting for them that would make sense, that wouldn't just be baloney, for lack of a better word?
Okay, can I just jump in? So I think the thing which concerns me a little bit about the Verra position at the moment is that setting a date for a few years' time to resolve this issue is a worry. I think that there's a really growing concern that these credits are not viable, and there are already responses to that which are withdrawing investments into these new projects, and that really, really worries me. I think we need to hasten up this process of iteratively improving. In terms of responding to your point just then, Carlos, I think the issue is that if you've got this high forest cover, low deforestation situation, you can't match within a jurisdiction so easily, right? So you have to match to a counterfactual set of similar regions.
So just to say, I know we've taken a long time with the release of this new methodology, but we will be trying to transition projects to it as soon as possible. And that means us, because the biggest step forward in this new methodology is Verra allocating the activity data to all the different projects. So we not only need to complete the methodology, which we think will be out in Q3 of this year, but also make the activity data available in every jurisdiction where there are RED projects around the world. So we've set the goal to have all of the activity data available by the end of 2024, and projects have to transition to the new methodology. Avoided unplanned deforestation projects have to transition to the new methodology by 6 months after it is available for use in their jurisdiction. So, or after activity data is available in their jurisdiction, and it just takes a long time. And I know that we're like a significant constraint on the market right now, and believe me, we all feel that pressure.
Thank you, Julie. So we start running out of time. So maybe for last question, I will just displace the debate a little bit and anticipating probably other challenges. A very quick reaction from all of you about any novel approach to measure the health, biodiversity, and other socioeconomic impact of this program. Today, we just talk about the additionality, but many other outcomes and anticipating whether there will be similar challenges than the topic we have discussed today. Probably starting with Julie, if you want to take that, or anybody.
I'm sorry, could you repeat the question?
Yep. So the question is like, today we discussed about the challenges about the carbon additionality, but similar issue will happen if we want to measure the biodiversity outcomes or the socioeconomic impact of programs. So I don't know if you have specific methodologies dealing with that, or any work in progress about how to I would say predict, but also verify these outcomes.
Yeah, so within Verra, or within the VCS standard, the Verified Carbon Standard, there are significant stakeholder safeguards and engagement metrics or engagement requirements. So that's one way, and they're more significant for affluent projects, and we're we're revising them this year, so they'll be even more significant. And we have the two other standards that I mentioned on the first slide of my presentation, the Climate, Community, and Biodiversity Standards and SD Vista, the Sustainable Development Verified Impact Standard, which can be used and layered with the Verified Carbon Standard to measure and have assessed by a third party the outcomes of those on those aspects of sustainable development and communities and biodiversity as well.
Any very short?
Very short, because we want to respect people's time. I have one last.
Well, I'm going to jump in again.
Okay.
I think we just have to recognize that where additionality exists, it's because there is an opportunity cost. There is some action that would have taken place in the absence of the project. And so we need to measure that opportunity cost and be explicit about that and think about the carbon benefits that we're receiving in the context of that opportunity cost.
Great, that's a great final comment, a broader issue. I want to thank the panel for participating. I thought it went excellent. It was a short period of time. You touched on some great issues. I hope people in the audience are more excited, engaged about this project. We need more brains on it. And I just want to make sure that for those of you who are not just signed up for this seminar, but want to keep participating, every Tuesday of every month, except for during the summer, we have one of these seminar series, hour-long Q&A from the audience. Next one will be theory-based approaches to impact evaluation. And we have two great presenters, Gabby Salazar and Jennifer Zavaleta-Cheek are going to be presenting. So I hope you can all join us then. Otherwise, big hand to our speakers and to our audience for staying with us. Thank you very much. See you all again. And we'll be making the chat available to the speakers so that you can see all the questions that were posed to you that we didn't get a chance to take a look at. Bye, everyone.